All right, lesson 3.4. This lesson sort of brings together all the concepts from the chapter and tests your understanding. So let's attack example 1, part A. All right, what's going to happen here? I have this exponent here, an x. All right, so I have this 1/4, I have 64. Now, I could relate these two numbers by the number 4, but using exponents. So 1/4 I could rewrite as 4 to the negative 1 power. And I have 64, which I could rewrite as 4 to the 3rd power. All right, and now I could just multiply these. I have 4 to the negative x power equals 4 to the 3rd. Then I get negative x is equal to 3. I'll divide by negative 1, and x is equal to negative 3. Done. All right, for the next one, let's see, what are we going to do here? I could apply the quotient rule here, but that's not really going to help me. I'm just going to add this over, and then you'll see how simple the problem becomes. All right, well, I have two logs that are equal to each other, so whatever I'm taking the log of, that must be equal to each other. All right, done. All right, next part. E to the x equals 4. I have this exponent here. How do you get it down? All right, well, I'm just going to convert this exponential equation into a logarithmic equation. So it's going to be log, whatever the base of the exponent is, that's what the base of your log is. And it's going to be log of 4, and that's equal to x. All right, here's another way to look at it. All right, you could simply just take log base e of both sides, okay, because whatever you do to one side, you do to the other. And then this essentially cancels out, and the x drops down. So you're left with what you have down here. All right, now I have log of 4 base e, and log base e is the same thing as natural log. So it's just the natural log of 4. All right. And if the problem wanted an exact answer, then you just plug that into your calculator. All right, on to the example. All right, solve algebraically. Okay, they give you a graph here, but since they say solve algebraically, you're just setting the functions equal to each other. All right, so not that difficult to work with. Now, what am I going to do here? I have this exponent here, but I could take 27. I could rewrite that as some power of 3. Same thing with 9. So this is 3 to the 3rd. It's the x power, and then I have 9, 3 to the 2nd. All right, so then I have 3 to the 3x power is equal to 3 to the 2nd. So I get 3x equals 2. All right, I get x is equal to 2/3. All right, and they're asking you to find the point of intersection. All right, so that's pretty easy. So I have the x value of where the graphs intersect, and you could just plug it into any function to find the y value, and I could plug it into this one, but there's nothing to plug it into, so the y value is just 9. So here's your answer for that. The graphs intersect at 2/3, 9. Okay, and for the next one, same deal. Set the functions equal to each other. Natural log of x minus 4 equals 0. Okay, now one important property is that when you take the natural log or the log of 1, what do you get? You get 0. So once again, if you take the log of 1, the result is 0. Well, the result of 0. So I just set x minus 4 equal to 1. All right. I get x equals 5. And once again, I could just plug it in up here. There's nothing to plug it into, though, so your y value is 0. All right, I'm done with that. On to the next example. Okay, so this looks like it has a quadratic structure to it. All right, so I could do something like this. I could do e to the x squared minus 5e to the x plus 6 equals 0. All right, so just imagine that you replaced the e to the x's with just an x. It would be a quadratic structure. All right, so just imagine the e to the x was an x. All right, treat it the same way. So I have to find two numbers that add up to -5 and multiply to give me 6. That would be -3 and -2. So I could factor this into e to the x minus 3 times e to the x minus 2 equals 0. All right, set each factor equal to 0. All right. Okay. And now I could apply, let's see, logarithm properties. I could convert this into logarithmic form. So it's going to be log base e of 3 equals x. All right, there we go. That's simple. I already isolated x. Same thing here. Convert to logarithmic form, base e of 2, and that's equal to x. All right, so then since I have log base e, I could rewrite the log as natural log 3. And for the next one, natural log of 2. Done. All right, for the next one, let's see what we're going to do here. Well, I have x in the denominator position here, and I have to get it out of there. So I'm going to multiply by the denominator on both sides. Okay, and I have 400 is equal to 350 times 1 plus e to the negative x. All right, then I could just divide by 350 now. All right, and 400 over 350 reduces to 8/7. And then I'm going to subtract 1, so I end up with 1/7 equals e to the negative x. Okay, I'm almost done here. All right, what can I do next? Okay, I'm going to convert to logarithmic form now to isolate the x. So I have log base e of 1/7 is equal to negative x. All right, I'm on to something here now. Divide by -1, cancels out, so I get x is equal to negative log of 1/7 base e. All right, and since I'm working with a fraction here, I can apply the, actually before I do that, I'm just going to write natural log instead of log base e. And then now I will write out the product property, natural log of 1 minus natural log of 7. All right, and I have negative of natural log of 1 is 0. It's minus natural log of 7. All right, and I'm going to distribute the negative, and I get natural log of 7. All right, that's what x is equal to. Done. All right, on to the next example. Okay, I have a natural log here. I'm going to rewrite it as log base e. So then that's going to help me convert this to exponential form. Yep, that's what I'm going to do. So I have the base e for my exponent. That's equal to x minus 8, the square root of it. Okay, and next step is to get rid of the square root. So I'm going to square both sides. And I have e to the 10th is equal to x minus 8. And then I'm going to add 8. So x is equal to e to the 10th plus 8. All right, done with that one. On to the next. Let's see here. I got all these logs here. Can I condense it? Yes, I can. I have the sum here. I could rewrite that as a product. Okay, and now I have two logs that are equal to each other. So whatever I'm taking the log of for each of them, those pieces are equal to each other. All right, so that certainly simplifies things. All I'm going to distribute here. So I get x squared plus 2x equals x plus 6. All right, subtract x. I get x squared plus x equals 6. X squared plus x minus 6 equals 0. All right, and then I'm going to factor now. So what two numbers add up to 1 and multiply to give you negative 6? That would be 3 and negative 2. So I have x plus 3 times x minus 2 equals 0. All right, so set both of these equal to 0 and solve, and I get, oops, it's a negative. Okay. All right, now typically students, all right, will box these answers. All right, but now actually one of these is extraneous. All right, and why is that? Okay, because whenever you're working with a logarithmic equation, all right, make sure to check your answers. All right, so if I take this negative and I plug it in here, I'm taking the log of a negative number, and you can't do that, so that can't be an answer. All right, but if I plug in just 2 into all these, it'll work out to be just fine. So x equals 2 is your answer, not both of these combined, just 2. All right, going on to the next problem. And the last one. All right, so 2,500 is invested in an account, interest rate 12%, compounded continuously. All right, so you have to use that formula. A is equal to the principal times e to the RT power. All right, now the principal is 2,500. That's the initial amount you're investing. And E, interest rate is 12%, so 0.12, that's R. Have to write it as a decimal. And find the time required for the amount to double. Oh, for it to double. Okay, so that means that the amount you have in the account is 5,000. So I have to figure out T. All right, interesting. So I'm going to first divide by 2,500. And I get 2 is equal to E 0.12t. All right, then I'm going to convert to logarithmic form. So I have log base E of 2 is equal to 0.12. All right. Actually, no, I messed up here. I goofed. Log, what do we have here? Yeah, it's 0.12, but it's 0.12t. That's what I'm missing. Okay, we're good now. All right, let's get t by itself, divided by 0.12. Okay, could also rewrite it like this if you want to have it in the most simplified form. Okay, and if you want to work it out on your calculator to get a precise answer, t is going to be 5.8. 5.8 years. All right. All right, that's all there is to it. We're done with the chapter now. If you have any questions, if you're confused about anything, make sure to ask for help. All right, begin the assignment at the bottom of the webpage.